PowerPoint to go through one way in which you can do metric conversions. There are lots of different methods. This is one that doesn't use a whole lot of math, so if you have some aversion to math, this might be one technique that you can use. When we look at the metric system, which is what we're going to be using in the biology lab, there are 4 main units that you're going to come into contact with. If you're measuring length, the main unit of measurement is the meter. The abbreviation is M. For volume or liquids, the main unit is the liter, and that's abbreviated by an L. For mass, the unit of measurement is the gram, or G, and then in temperature, we use Celsius, or C. As far as the conversions, we're not going to talk a whole lot about Celsius, but we will talk about meter, liters, and grams. So we can consider these our base units, and then if we want to talk about maybe a very small amount of liquid or a very large amount of liquid, we can add prefixes to liter, for example, to indicate a smaller unit or a larger unit. So here are all the prefixes. You can see here is the base unit right in the middle, grams, meters, or liters, and that has a multiplier of 1, or we can also consider it 10 to the 0 power. So that's sort of our starting point. If we want to talk about things that are smaller, we go upwards on the chart, and we use the prefixes deci, centi, milli, micro, nano, and pico. If we want to talk about larger units, we would go down on the chart, and then we have the prefixes deca, hecto, kilo, mega, giga, and tera. And this chart is in your lab, so don't feel like you have to copy it all down. As we go up the chart into smaller units, you can see that our powers of 10 decrease. So we have 10 to the negative 1, 10 to the negative 2, 10 to the negative 3, and then we skip to 10 to the negative 6. As we increase, our powers of 10 increase, 10 to the 1, 10 to the 2, 10 to the 3, etc. And remember, when you are taking something to the power of 10, you are multiplying 10 by itself. So if you have 10 to the second power, that's the same thing as 10 times 10, or 100. Okay? Similarly, if you have 10 to the negative 2, that's the same thing as 1 over 10 squared, which is the same thing as 1 over 100. So this is going to be a decimal point. So this is stuff that you're going to have to keep in mind when you're making these conversions. On the chart here, I have put into blue the ones that I expect you to memorize. So you need, and these are the ones that we use most frequently. So I'm not going to make you memorize the ones that we really don't use in laboratory measurements. So again, always the base unit. As far as larger units, you should know kilo, which is the same thing as 1,000 times bigger than the base unit, or 10 to the third. Okay, so we'll need to know kilo is 10 to the third. In the smaller units, you should know centi, milli, and micro. And we use these a lot in the lab, so you'll see them this semester. So centi is the same thing as 10 to the negative second, or 1/100th of the base unit. Milli is 1/1000th, 10 to the negative third, as compared to our base unit of grams, meters, or liters. And then micro is 1/1,000,000th, or 10 to the negative 6th. So for me, it's easier to remember that micro is 10 to the negative 6, milli is 10 to the negative third, centi is 10 to the negative second, and kilo is 10 to the third. And I'll show you how we can use this scientific notation to make conversions between our base unit and some of these other units. So the way that I remember it is if I want to make a conversion from a larger unit to a smaller unit, I'm going to shift the decimal point, and it's going to go to the right. Okay? And it's going to go to the right as many places as the power of 10 differs. The opposite is true if I'm going from a small unit to a larger one. I'm going to shift the decimal point to the left. So let's go through some examples and I'll show you how this works. Okay, here's our first example. 17.4 meters equals how many centimeters? So let's put it on the board and we'll work through this one. 17.4 meters, and we're converting that into centimeters. So meters is the same thing as 10 to the 0 power, that's our base unit. Centimeters is the same thing as 10 to the negative second. So I'm going from a larger unit to a smaller unit. So I'm going to move my decimal point to the right. How many places am I going to move it? I figure that out by subtracting my powers on my 10. Okay, so the difference between 10 to the 0 and 10 to the negative 2 is a power of 2. So I have 17.4. I'm going to move my decimal point 2 places to the right, and in 17.4 meters, there are 1,740 centimeters. Let's do another example. Let's see what we have next. 148 milligrams is the same thing as how many grams? Okay, so this one is different. We're going from a small unit of milligrams to a larger unit of grams. So we're going to have to move the decimal point in an opposite direction. So let's write this one on the board, and we can go through the same process. 148 milligrams is the same thing as how many grams? So this is 10 to the negative third. This is 10 to the 0. So I'm going from small to large. I'm going to move the decimal point to the left. How many places? I'm going to subtract my powers. The difference between 3 and 0, negative 3 and 0, is 3. So 148, my decimal point is here. I'm going to move it 3 places to the left, and I have 0.148 grams is the same thing as 148 milligrams. And when you do this on your quiz, it's going to ask you to put the leading 0 in your answer, so I included the 0.148 when I wrote out my answer. Okay, let's go through. I have 2 more examples. Okay, this one's a little bit more complicated. We have 24.6 kiloliters, and we're converting to microliters. This again is one where we're going from a larger unit to a smaller unit, so we're going to have to move the decimal point to the right. But this one's a little bit different because we are not going to our base unit. We're going from 2 different units that are not base units. So 24.6 kiloliters is how many microliters? So this is large, this is small. We're going to move the decimal point to the right. Let's figure out how many places. Kiloliters is 10 to the third. Microliters is 10 to the negative 6. So if we have the powers, 3 minus a negative 6 is the same thing like 3 plus 6, so it's a difference of 9. So we're going to have to move that decimal point 9 places to the right. So 24.6, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a lot of microliters in a kiloliter. Okay, this is as hard as it's going to get for you guys this semester. I won't make it any more complicated than this one.